Well, as it says here, the square root of a number is the reverse operation of squaring a number. So what does that mean? Well, first of all, we need to understand what the symbol is. So the symbol that you see here, kind of like a tick, that means find the square root of whatever number is underneath it. For example, if I've got 5 squared, we write 5 with the power of 2 above it. It means 5 times 5 is 25. So the square root's the opposite of this. So it's like we're getting the 25 and we need to get back to find out what number did we square. We're trying to find this 5. So the square root of 25, we think, okay, that means 5 times 5 gives me 25. So my answer is 5. So to find the square root of a number, that's what we're thinking. We're thinking, what number do we multiply by itself to equal the 25? So to find the square root of 16, we think, okay, what number do I multiply by itself to get 16? Well, that's 4 times 4, so the square root of 16 equals 4. And again, square root of 81, what number times itself gives you 81? 9 times 9 is 81, so the square root of 81 is 9. Square root of 64, 8 times 8 is 64, so the answer is 8. The square root of 121 is 11 times 11 is 121, so the answer is 11. We can find the square root of larger numbers without a calculator by just using the prime factors that multiply to give the number. So if we were given the fact that 324 equals this great big long multiplication, which we can find using factor trees, all we need to do is split them into our prime factors into 2 identical groups. So I've got 2 2's, so one of the 2's goes into one group, the other 2 goes into the other group, and we keep splitting the 3 into one, the 3 into the other. So it would end up looking like this. So that 2 would go there, the other 2 would go there. One of the 3's there, one of the 3's there. 1 3 there, and the last 3 over to here. The square root is one of these groups. So we just work it out by going, okay, one of the groups is 2 by 3 by 3. 2 times 3 is 6. 6 times 3 is 18. So the square root of 324 is 18. The second example, given that the square root of 1329 equals the square root of it in its prime number, product of its prime numbers, we just split it into our 2 equal groups. So you should be able to go one of the 2's there, the other one there, that one there, that one there. A 3 here, a 3 there, a 3 here, a 3 there. Split it into the 2 equal groups. So the square root will be one of these groups. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. The other thing we need to do is find the cube root of numbers. So that's the reverse of cubing. Here's our symbol. We have to have this little 3 right inside this little tick part. It can't look like the number outside the front here. It has to be right up in above the little part of the tick. And that means find the cube root of the number underneath. For example, when we've got 5 cubed, oh, I've got too many signs there. Ignore one of those, please. 5 times 5 times 5 is 125. So the cube root of 125 is just the 5. To find the cube root of 125, you're thinking, what number multiplied by itself 3 times gives you 125. So the cube root of 8, 2 times 2 times 2 is 8, so the cube root of 8 is 2. The cube root of 64, that's 4 times 4 times 4, so the answer is 4. Now, the third one here, kind of tricky, but the more you see them, the easier they are to recognise, and that one's 7. For larger numbers, we do exactly the same as we did for the square root, but instead of doing it into 2 identical groups, we have to have it into 3. So here's our example. We have to break this section here up into 3 identical groups. So there's 1, 2, 3, 4, 5, 6 2's. So there'll be 2 2's in each of the 3 groups. There's 3 3's, so there'll be 1 3 in each group. So in 3 identical groups, they end up looking like that. So our cube root is one of the groups. And that's why 2 times 2 is 4 times 3 equals 12.